This video is to explain section 3 within lab 4. Basically, we're going to be combining what we happen to do for section 2 and 3, and we're going to have a series parallel combination where we'll have a series branch of a 470 ohm resistor with a 20 nanofarad capacitor and a 10 millihenry inductor with a 1 kilo ohm resistor. This guy here, this 100 ohm resistor, is actually going to be used as a sensor resistor. I've kind of found out that if you happen to use a lower resistance, so I mean for me, I have a 10 ohm resistor, my values will they'll get really noisy, so I find it better to use at least a little bit of a bigger resistor. But anyway, this is what the circuit is. I don't know if you can see, but these two don't actually touch. The two branches, they're kind of just shifted a little bit so that the top connections actually touch, but right here they're actually separated. So we're going to go over to our wave gen here, using the same 8 volts peak to peak with a 10 kilohertz frequency. So we're going to turn both the wave gen and the scope on, and you can kind of see how, like, what I mean about it's being like it's kind of noisy, how there's a little bit of a ripple within your waveform, and if you had a smaller resistor, that ripple would be much greater. But we're going to be doing pretty much the exact same thing that we've been doing, where we're going to be comparing the source voltage with both the source current, which is what I'm measuring right now, as well as the current going through both parallel branches. So what I got here is the channel 2 is measuring the 100 ohm sensor resistor, and the red guy here, the math 1, is taking that channel and dividing it by 100. So you'll notice that I'm getting, for a peak-to-peak value of that M1, is around like 10.9 to 11 milliamps. And what you would basically do is start from one part of where this orange waveform would cross the pretty much the origin, and take the period, which is going to be your D1, which in this case is 100 microseconds, and then take the distance from here all the way over to where these guys go across the x-intercept here, and find that distance, divide it by the period, multiply it by 360, and you should get the phase angle difference. The nice thing about this circuit here is you're able to take the voltage that's going across this 470 ohm resistor, as well as this the voltage going across the 1k ohm resistor, and you can calculate out the currents going through it by just taking that voltage and divide it by the resistor value. It makes it easier because you don't actually need a sensor resistor, because you already have a resistor that are in each of those branches.